Okay, today we're going to be learning about how to solve a system of equations using the elimination method. So far you've learned graphing and substitution, and then this is what we call the elimination method. Sometimes this is called combinations because really what you're doing is you are combining the equations and eliminating. So I'm just going to write that right here. We are combining, and to combine you're going to want to add them together, and then that's going to help us eliminate one of the variables. Sounds complicated right now, but I have a pretty good idea that you're going to be just fine. So notice here how in my first example I have two linear equations. Both of them are written in standard form. Now right now they wouldn't be very easy to graph, so graphing method wouldn't be probably our best choice. And then also notice that neither one of the equations is solved for x equals or y equals, so we have no package to plug into the other equation. But if you do notice, being that these two equations are written in standard form, the x's are lined up, the y's are lined up, and then our constant over here is lined up. So they're actually lined up perfectly for us to add them together. Now I know this sounds crazy, but you can actually add the two equations together to get the solution of where they're going to cross on a coordinate plane. Remember, that's the solution to a system. Now the goal here is to add the two equations together and solve for one of the variables, which means we only want one variable. So we want one of our variables to cancel out. Now notice here, if I add these two equations, this positive 4y and the negative 4y will make 0. So let's add the x's. 3x's and 5x's make 8x's. And then let's bring down the equal sign here. Now remember, the 4y and the negative 4y made 0, so I just cancel them out. Then I have negative 22, and I'm going to add 38, and that's 16. Now I have one equation with one variable, so let's solve for x. Pretty cool, huh? So now I know that my x coordinate is positive 2, so I'm going to plug that right here. Now what we need to do is find the y coordinate. Well, you will have to use the substitution method in order to find the y coordinate. So you're going to have to pick one of the equations, whichever one you think is easiest, and it really doesn't matter here. And I'm going to plug in x is 2. So I'm going to use the top equation, 3x plus 4y equals negative 22. And I'm going to take this x and plug it right in here into the equation for x. So remember, x equals 2, so we're going to plug in 2. Now I'm going to solve the equation for y. Negative 22 minus 6 more. I get y is equal to negative 28 divided by 4 is negative 7. So my y coordinate is negative 7. Pretty crazy that we can add the equations together and get the solution, but you can. Now if we were to graph these two linear equations on a coordinate plane, they would cross at the point 2, negative 7. All right, let's take a look at number 2. With number 2, again, we do have two equations that are written in standard form. You probably noticed that this first one isn't correct because there's a negative in the front. But nonetheless, it's the x plus the y equals the constant. So the best method here would be to use elimination. We could just add the equations together, and we could solve for the point in which where they're going to cross. But notice that if I just go to add these two equations together, to combine them together, a negative 2x and a 3x is not going to cancel out and make 0. And a 12y and a negative 4y is not going to cancel out to make 0. So I'm going to have to change one of these equations. Now you know that if we multiply a number to both sides of the equal sign in an equation, the equation remains true. So I want you to think about, what could I multiply one of these equations by so that I could get either the x or the y to cancel out? Do you see here how this is positive 12y? Could I change this 4 into a 12 as well? You could. What if I took this negative 4y and multiplied it by 3? Wouldn't it be a negative 12y? And then these two could cancel out. So I think what I need to do here is to multiply this entire bottom equation by 3. I'm going to triple everything in that bottom equation. Now the top one will remain the same. So let's just copy that one over here. But the bottom equation, we're going to triple everything. 3 times 3x, 9x. 3 times negative 4y, negative 12y. And 3 times 17, 51. Now, if we take a look at these two equations and try to add them together, you will see that the positive 12y and the negative 12y can cancel out. That's 0. So let's add everything together. Negative 2x plus 9x, 7x. Remember, bring down the equal sign. Then I have a negative 30 plus 51, and that's 21. Now let's solve for x. I get x equals 3. So now I know that these two lines are going to cross and the x-coordinate is 3. So I'm just going to go right over here because I have some space, and the x-coordinate's 3. Now we need to find the y-coordinate. Remember, to do that, I have to substitute. I'm going to take x equals 3 and plug it into either one of the equations. Let's just use this bottom one here. It says 3x minus 4y equals 17. And since x is 3, I'm going to replace the x right here with a 3. Okay, so I'm going to subtract the 9. Eight divided by negative 4, negative 2. And I have my y-coordinate is negative 2. So if I were to graph these two linear equations, they're going to cross at the point 3, negative 2. That is the solution. Pretty cool, huh? You get to add the equations together, cancel out one of the variables, and then we take the one we solved for and plug it back in. All right, so you got to see two examples here. Let's take a look at number 3. Now, number 3 is again very different. We have two linear equations, and they're both in standard form. But you'll notice here that if I just go ahead and try to add them together, the x's don't cancel out. They don't make 0, and neither do the y's. The goal here is to get one of the variables to cancel out. Remember what we did in the last one, how we multiplied one of the equations by 3, and then we got it to cancel out? Okay, notice here that if I try to multiply just one of the equations by a number, I still don't think I'm going to get a variable to cancel out. Do you see how both of these are already positive? I notice that both of these are opposite signs. And I know if I add opposite signs, I can get them to cancel. So take a look at this negative 7y and the positive 2y. Is there a number that I can change 7 and 2 into? Think about the multiples of 2 and 7. What do they have in common? 14? Okay, so let's take this top equation and we're going to change this negative 7 into a 14. So that means I have to double it. So I'm going to double everything in the top equation. Now the bottom equation, in order to get this 2y to change into a 14, I'm going to have to multiply everything in the bottom equation by 7. Hopefully you can see that 7 right there. So let's double the entire top equation, and we're going to write that here. 2 times 14, 2 times negative 7y, and then 2 times the 21 on this side. Okay, now the bottom equation, I'm going to have to multiply everything by 7. 7 times 10, 7 times 2y, and then 7 times the 22. You can use a calculator for that if you need to. Now let's see if we can add these two equations together and have a variable cancel out. Okay, negative 14y and a positive 14y, that makes 0, so those cancel out. So now we're going to add the 28x's and 70x's to get 98x's. Bring down the equal sign. 42 and 154, 196. Now I have to divide by 98. And then again, a calculator for this to divide will give you 2. So I have the x-coordinate is equal to 2. All right, so I know that the lines are going to cross, and I can see that, well, let's see, let's put it up here. Here's my point. My x-coordinate's 2, so I'll put that right here. Now, in order to find the y-coordinate, I have to take x equals 2 and plug it into either one of the equations, whichever one you think is easiest. I think I'm going to pick the bottom one right here. So I'm going to write it right here in my notes. Remember, I'm going to plug in x equals 2. So 10x, 2y plus 2y equals 22. And I know that the x is 2. So you see where that x is? I'm going to put that right here, make that a 2. Now let's solve for y. I got y. Y is 1. Hopefully you agree. There's my point, 2, 1. So it looks like the solution to this system is 2, 1. These lines are going to cross at the point 2, 1. Now I just want to show you that this actually works, because you might be thinking this is crazy. We can just add these two equations together and find the solution. How does that even work? I want to take both of these two equations that they gave us, and I want to rewrite them so that I can easily graph them, and I'd like you to graph them along with me. So we're going to take both equations and rewrite them y equals mx plus b. I'm just going to do that right here. I have some room. So my first equation, 14x minus 7y equals 21. And then the second equation was 10x plus 2y equals 22. So I want you, along with me, to rewrite both of the equations, y equals mx plus b, so we can easily graph them on the coordinate plane. What I want to do is show you that we actually do get the point 2, 1. Okay, I have that one. Almost ran out of room there, but I have that one. So we have the two equations. Y equals 2x minus 3 and y equals negative 5x plus 11. Now what I'd like to do is to show you how if I do graph this on a coordinate plane, I'm actually going to have these two equations cross at 2, 1. So let's try it. Let's take the first one and graph it. Intercept's at negative 3 and slope is 2, up 2 over 1. I'm going to make just a few points and connect the line. Now I'm going to take the other equation, and I'm going to do that one in this green color, okay? So this time the intercept is at negative 11. I'm sorry, positive 11. Oh gosh. All right, so let's go all the way up here at positive 11. I think this is 10. If I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just wanted to make sure. So that's up here at 11. There's 11. However, my slope is negative 5 over 1. That's rise 5, run 1. But I can't rise 5, I'd be off the graph. So instead of rising 5, I'm going to fall 5. So I'm going to drop 5. 1, 2, 3, 4, 5, and run 1 to the right. Do you see now if I connect that line, it's going to be a downward negative slope. Okay, then again, drop 5. 1, 2, 3, 4, 5, and over 1. There they go. That's where they're connecting. 1, 2, 3, 4, 5, and over 1. So I'm going to connect the line here, or connect the points to make a line. And then that's where they connect. So I'm going to try and see if I can blow this up just a little bit on the video. Now here is our origin right here. Looks like if I go to the right 2 and up 1, I land on the point. And we know that the solution that we got was right here, 2, 1. Even with the graph, I get the solution 2, 1. How cool is that? Maybe I just think it's super cool because I'm a math teacher. But there we have it. We checked it and it worked out. So now you know that you really can add the equations by using this elimination method and really get the correct answer. So there is all that work. Check it out. Here's the elimination method. We did that and got the solution 2, 1. And then we checked it by just rewriting it and graphing, and we still got the solution 2, 1. Super cool. Okay, let's look at the last one now. I have a kind of a word problem here, a real-life application of how you can use systems of equations. Okay, here we're at a St. Paul Saints game with a large group of friends and, best of all, a rich uncle. Don't we all wish we had one? Your uncle spends $267 on lunch. He buys 87 hot dogs and soda pops. Each hot dog costs $5 and each pop is $2. So I want you to figure out how many hot dogs and how many soda pops were bought. We know that there was 87 total, but how many of each kind were purchased? You can use a system of equations in order to figure this out. So we need to set up 2 equations. Well, we know that there are 87 hot dogs and sodas. Let's use H to represent hot dog. And you heard me say soda pop. Instead of S for soda, because it looks like a 5, I'm going to use P for pop. Okay, so 87 of each that were bought. So would you agree with me that if we took all the hot dogs plus all the pop and added them together, there'd be 87? So let's write an equation that represents that. I can take all the hot dogs plus the pop, and the total of them is 87, right? Now I just need to figure out how many of each of them there are. Now the second equation is going to have to do with the money. Because remember, he spent $267. So my second equation will be money. Now I need to write an expression for the cost of the hot dogs plus the cost of the pop equals the total cost. Now we know the total cost is $267, so I can put that here. But what expression would represent the cost of the hot dogs? Remember, they're $5 each. So maybe $5 times the number of hot dogs. And then the expression to represent the cost of the sodas. Maybe $2 times the number of soda pops. Now I have 2 equations. Both of them are written in standard form. Think of this as the X and this is the Y, right? So this equation has to do with how many of each were bought. And this equation has to do with the money or the value of everything. Notice that the H's are lined up, the P's are lined up, and the constant is lined up, so we could just add them together. But you probably noticed that if I just go to add these 2 together, the H isn't going to cancel and neither is the P. So I'm going to have to multiply one of the equations by a number to get something to cancel out. Well, here's a 5, here's a 2. I could make up here this a negative 5H by multiplying the entire top by negative 5, and then the H would cancel. If I multiply the top by negative 2, this would become a negative 2, and the P would cancel. So you kind of have a choice here, what you want to do. Do you want to multiply everything on the top by 5, or do you want to multiply everything on the top by negative 2? Well, 2 is a smaller number, so we could go with 2, but it really doesn't matter. Let's multiply everything up here on the top by negative 2. So I'm just going to go right over here to the side, and I'm going to rewrite this equation. Negative 2, and again, I'm multiplying everything by negative 2. and negative 2 times 87. Okay, now the bottom equation is going to stay the same. We're not making any changes to that. Now I can add them together. Negative 2h plus 5h, 3 hot dogs. Now negative 2p and a positive 2p, we got them to cancel out. Bring down the equal sign. Now you're going to need to use a calculator. Negative 174 plus 267. It's fine to use a calculator. If you use one, you'll get 93. Now let's divide by 3. And the number of hot dogs is 31. So we have 31 hot dogs that were purchased. Cool. Now we need to know how many soda pops. Now look at the two equations. We're going to have to do substituting. Which one's easiest? You would probably say this one. The number of hot dogs plus pop is equal to 87. Well, if you bought 31 hot dogs, how many pops would you need to buy to get 87? So here's 31 hot dogs. Remember, I'm just replacing the h plus p equals 87. Well, clearly just a quick calculator would help you with this. But if I subtract here, I get 56. So I know that 31 plus 56 gives me a total of 87. 31 hot dogs were purchased and 56 soda pops were purchased. So I have 31 hot dogs and 56 sodas. All right, Rich Uncle, super fun time. All right, and there you have it. This is lesson 6-3A. Thanks for watching.